Today we are looking at the actual physical infrastructure needed for high-end video.
Yeah, the stuff that makes it all possible.
Exactly. We're using the Kramer CLS-AOCH 131 HDMI cable as our source material to really unpack what it takes to send a signal a long, long way.
Mm-hmm.
So let's just jump right in. Why do these advanced setups, think stadium screens, huge corporate installations, why can't they just use standard copper cables anymore?
It really just comes down to physics. Pure and simple.
Yeah.
Standard copper, it just runs out of steam almost immediately when you try to push the massive data rates that modern video needs.
You're talking about signal loss.
Signal loss, interference, you name it. Trying to send 48 gigabits per second over, say, 50 feet of copper is, well, it's basically impossible to do reliably.
But this cable is the solution.
This is the technical solution.
Yeah.
It's a hybrid. It uses fiber optics for the heavy lifting, the data, and then copper for things like power and control signals. It's literally a roadmap for how you do 8K video over real professional distances.
Okay, that brings us right to performance. We're talking about signals that fully embrace the HDMI 2.1 spec. What are the actual numbers here?
We are dealing with the absolute bleeding edge. You're looking at resolutions up to 4K at 120 hertz and even 8K at 60 hertz.
And the data rate for that has to be just astronomical.
It is. The cable has to sustain up to 48 gigabits per second. But what's really fascinating here is the trade-off you see right away.
A trade-off. How so?
Well, to squeeze that 8K at 60 hertz signal through that 48 Gbps pipe, you're often using something called 4.2.0 chroma subsampling. It's a form of compression, basically.
So you're making a small sacrifice in color information to hit the distance.
Exactly. It's a necessary compromise to make these incredible lengths possible. The specific one we're looking at is 131 feet long.
And this tech can go even further, right?
Oh, yeah. Up to 100 meters, which is, about 328 feet? And it does that while being incredibly flexible. Because it's mostly fiber, the cable is super thin, only about 4.5 millimeters. Much easier to work with than thick, heavy copper.
Okay, here's where it gets really interesting for me. This is an active optical cable. What does that mean for the installer?
It means that there are tiny electronics chips inside the connector heads themselves. They convert the electrical signal to light and then back again at the other end.
And those get power from the source device,
Yeah.
like the media player or the display.
That's right. The upside is, it's simple, no extra power bricks. The downside is that those active ends, even though they're high quality, 24K gold-plated, are a lot more sensitive.
So you have to be more careful.
Much more careful. You can't just crush it or bend it sharply. But the benefit is huge. The fiber core is immune to EMI and RFI. That's the electromagnetic interference that plagues long copper runs.
And there are other professional requirements too, right? I'm seeing acronyms like LSHF and TAA compliant.
Yeah, and those are crucial. LSHF means low smoke, halogen-free. That's a huge fire safety requirement for commercial buildings. If it burns, it won't release toxic smoke.
Okay, and TAA.
That's for government and military projects. It certifies the cable was made in a friendly trade agreement country. So this thing is built for high-end, high-security installs.
So let's tie this all back to the user experience. It's not just about the picture.
Not at all. It handles the whole HDMI 2.1 package, HDCP 2.2, which is your content protection, HDR for better video, and EARC, the Enhanced Audio Return Channel.
Meaning you can send high-end audio back from the display to the source.
Precisely. We're talking Dolby True HD, DTS HD master audio, all sent seamlessly back down that 131-foot run. It's also using something called display stream compression, or DSC, which is what really makes it all work within that 48 Gbps limit.
So to sum it all up, this kind of sophisticated active hybrid cable is really the only way you're going to get the highest quality video-like 8K or 4K at 120 frames over the distances professionals need.
That's the bottom line.
And this specific cable, it's listed for around $432. That's a serious investment, but it's backed by a 3-year warranty.
It is. And what this all means for the future, it raises a really important question for me.
What's that?
In a world that's demanding higher and higher resolution, higher frame rates, how far away can we actually put our displays before the cable itself, this fragile, powerful, active thing, becomes the ultimate limiting factor? You're investing to solve today's problem, but tomorrow's video standards are going to stress even these limits all over again.